Okay, in this video, we are going to integrate this rational expression. And remember, we have to check the degrees first. The degree on the top is 2, and the degree on the bottom is also 2. When the degrees are equal, we also have to do long division. So here we go. Let me just put this down on the side for you guys. The top goes inside 3x squared plus 6x minus 54, and then the bottom goes on the outside, x squared plus x minus 20. And here we go. Look at the first term inside and then the first term on the outside. What times x squared will give us 3x squared? We just need to have a 3, right? And that's a constant. Let me just put it down right here, line up with a constant term. And then we do 3 times x squared. That's just 3x squared. And then 3 times this is plus 3x. 3 times that is negative 60. And then don't forget we subtract. And let's see. 3x squared minus 3x squared is 0. And then 6x minus 3x is 3x. And then negative 54 minus minus. In another word, negative 54 plus 60, we get positive 6, like this. And this is pretty much it. We have 3 and 3x plus 6 over the original denominator. So this is how we can reduce the expression. And now let's put this down right here. This integral is the same as the integral. Let's write down the 3 first. And I will put down this over that next. And I will just say plus this over that, which is 3x plus 6 over this, which is x squared plus x minus 20, like that. And then, of course, we'll have the dx. Now, this right here, it's very easy to integrate. The answer to that is just 3x. This part right here, we have to do partial fractions now. And of course, to do that, we will have to factor this. So let's go ahead and factor that. X squared plus x minus 20, we end up with x plus 5 times x minus 4. And let me show you guys the partial fraction on the side. We can actually do this by the carve-out method, which is really good. So let's write down 3x plus 6 over that denominator, which is x plus 5 times x minus 4. Well, we know this right here, it's going to be some constant over x plus 5. And we'll just put down the constant to be a. And then we add the next number, which is just b over this, right? Because they're just linear factors. Now, let's find out what a is. Well, a is equal to, look at this denominator, go back to the original fraction, cover the same denominator. Well, how can you make x plus 5 equals to 0? X has to be negative 5. So that means I have to plug in x equals negative 5 into the rest of this x, right? This is covered up already. So on the top, we have 3 times negative 5 plus 6 over negative 5 minus 4, like this. And on the top, let's just work this out. This right here will give us negative 15 plus 6 is negative 9 over this is also negative 9. So of course, this is just 1. A is 1. That's nice. Okay, for B, we do the same thing. Look at this denominator, cover this up. How can we make x minus 4 equal to 0? X has to be 4. So I plug in x equals 4 right here into the rest of the x's. So we will have 3 times 4, and then add 6 over 4 here, and then plus 5. Plus 5, like this. On the top, this is 12 plus that is 18 over 9. Of course, that's 2. So B is nicely equal to 2. Okay, so I will actually write this down right here for you guys real quick. This right here, all we have to do is the integral of 3, and let's close that. And then let me just write down this part in blue for you guys. We have the integral, and then this right here is the same as this plus that. So I will write down 1 over x plus 5. And then let's put down the next one, which is 2 over x minus 4. 2 over x minus 4, like this, dx. Alright, so I just want to show you guys this part is from this part, that's why I closed this integral in blue. and this right here is just pretty much by itself. And now, of course, we can just integrate this. Integrating 3 in the x world is just 3x, and then integrating 1 over x plus 5. This is x to the first power, and this is everybody's favorite because that's the natural log. Right? You add natural log absolute value of x plus 5. And check this out. The derivative of x plus 5 is 1, so you don't have to divide anything. And then continue. So we add 2. Right? You put on the constant multiple, and then now you have to deal with 1 over x minus 4, which is also the natural log absolute value x minus 4. And again, the derivative of x minus 4 is just 1. Therefore, we don't have to do anything else. And we're all done. Put plus c, and this is it. Right? So, again, whenever you are trying to integrate a rational expression, if the degree on the top it's the same or bigger than the degree on the bottom, we will have to do long division. And then depending on what kind of this fraction is, especially if the denominator is linear factors like this, of course, we can do the partial fraction by the cover up. So this wasn't too bad, and hopefully you guys all find this video to be helpful. Let me know if you guys have any questions, and if you guys are new to my channel, be sure to subscribe. Thank you guys so much, and as always, that's it.